Okay, hi everyone. Here I am for Riot Lesson 12. And we've worked our way through the bones of the spine. So we're going to talk a little today about the ligaments of the spine. So kind of hearkening back to our conversations at the beginning of the term when we were talking about connective tissue. Ligament is sort of, if we think of connective tissue as the most sort of crystallized of connective tissue being bone and the least blood, yeah. Ligament is going to be the next, I guess, dense and the next dense form of connective tissue after bone. Yeah. So ligaments are strappy fibers that connect from bone to bone. Right? I think we went over this at the beginning of the term, as opposed to tendon, which connects bone to muscle. Yeah, so a ligament always goes bone to bone, and thereby they're close into the bones, right? So they share a proximity to bones and joints that makes them ideally suited for to help with support, right? So helping the bones stay in relationship to each other, and thereby helping to facilitate the passage of weight through the bones, through the joints, clearly through the whole skeleton, head to toe. So we've got zillions and millions of ligaments in our body. And the cool thing about ligaments is often in the name of the ligament tells you which bones it connects. Like, for instance, there's a coracoclavicular ligament that attaches your coracoid process to your clavicle. And there's a pubofemoral ligament that attaches your pubis to your femur. And there's a sacrotuberous ligament that connects your sacrum to your ischial tuberosities, to your sits bones. So often in the name of the ligament you can tell what it's connecting, and you know that its function is to create sort of not elastic stability, but dynamic stability, yeah, at those joints. Again, helping the bones to relate to each other in a way that allows for a little bit of movement, yeah, but not too much movement, yeah, so that the bones slide out of relationship to each other. So the ligaments aren't bone, right? So they offer a little more movability or flexibility in their support, but not so much that bones are sliding out of alignment or out of a relationship to each other. So they provide a really important support function, and definitely assist in that task of allowing for a little bit of movement in a lot of places. Oops, let me just turn my phone off. Sorry. What else did I want to say? So in terms of the characteristics of ligament, we talk about ligament being flexible but not elastic. So flexible meaning it allows for movement. So this is my little snake toy that I like to use to talk about flexibility. Yeah, so this is flexible insofar as it's able to move, right? But it's not elastic because I can't pull it apart in the same way I can something like a TheraBand. Yeah, this is elastic. Yeah, and elastic and flexible. Yeah, elastic and flexible. This is flexible but not elastic. Yeah, so this is more akin to ligament. The TheraBand would be more akin to muscle. Yeah, and tendons have a little more pull than ligament, a little bit of stretch, but not the kind of contractile force of stretch that muscles get. Yeah, so that's kind of where ligaments exist on the spectrum of connective tissue and the function that they serve. I put up on Google Classroom a bunch of pictures of the ligaments. We're not going to talk specifically. I want to talk about specifically there's a set of ligaments that run all the way from the head to the tail and provide again, a sort of continuous support that's also dynamic from head to tail. So I want to look really specifically at those ligaments. Also, aside from those ligaments that run all the way the whole length of the spine, there are little ligaments in between all the vertebrae that are also helping on a more minute level each vertebra relate to the next one. So I put up one photo of that. I don't have it printed out, but it's this one. I don't know if you can see it. This one that shows all the ligaments in a little cross section of the vertebra. And again, the name tells you where the ligaments go to. So there's a costotransverse ligament. Yeah, costo always means rib, and transverse in this case refers to the transverse process. So a lateral costotransverse ligament is going to go from a rib to a transverse process. Intertransverse ligament, you'll also see, that goes in between transverse processes. There's another costotransverse ligament, etc. So you can see in this image all the little ligaments that are going from vertebra to vertebra, helping them talk to each other. Yeah, and then we're going to talk about the, like I said, the longer ones that span head to tail. So I have a couple diagrams of those up on Google Classroom as well. And unfortunately, the colors are not coordinated between the drawings and between the images that have tape on them. So you'll have to bear with that inconsistency. But let's start, let me see, let's start with, let's just start sort of conceptually. So as you know, there are, if you recall the anatomy of our vertebral structures, right? There is the body of the vertebra that go all the way down in the front of the spine, and on either side of the bodies of the ligament, on the front, on the anterior, and on the back, on the posterior, there is a ligament that runs all the way the length of the spine, sort of like, that's thick and wide, like almost like a strip of packing tape. Yeah, that like sort of packing tape that goes like packing tape along the front and packing tape along the back of the bodies of the vertebra. And this, I happen to have the squash on my desk. If you imagine that this is the head, yeah, and the spine is dangling off here, yeah, there's going to be a ligament that comes along the back of the bodies of the vertebra and one that comes along the front, and between them is the weight-bearing part of the spine. Yeah, so these ligaments are on either side, the front and the back of the spine, hugging the vertebra and allowing for that kind of hugging support all the way down. So on the photos that I put up that show a cross-section of a vertebra as well as the skull for the connections. The yellow, let's just talk about the anterior longitudinal ligament and the posterior longitudinal ligament. Yeah, so the anterior longitudinal ligament is yellow in those pictures, and the posterior is blue. Yeah, so, and let me make sure I say this right. So I want to get the attachment right at the top. So the anterior longitudinal ligament runs along the front of the vertebral bodies, the anterior surface, hence anterior longitudinal ligaments of the vertebral bodies all the way down. And it attaches, let me make sure I get this right, and attaches to the inferior surface of the basilar portion of the occiput. You remember the basilar portion of the occiput, the front of the occiput that's in front, or the part of the occiput that's in front of the foramen magnum, where the occiput articulates with the sphenoid. So the inferior surface, meaning inferior, meaning well, look at the picture because it's hard to describe, and I unfortunately don't have a skull. But as let Let me see if I can pull it up. I think actually I'll just leave it there. I think from the picture it'll be clear. If you look at where the yellow tape attaches on the skull, you'll see where the anterior longitudinal ligament attaches. Yeah, and then the blue is the posterior longitudinal ligament, and it connects to the superior surface of the basilar portion of the occiput. So meaning it's going to go up and attach to the top, or what would be the inside of the occiput, of the basilar portion of the occiput. Yeah, and then come down along the backside. In these drawings, again, I apologize that the colors don't match up. We're looking at a side view, yeah, of the spine, and this is the front of the spine. Those are the bodies of the vertebra, and these are the spinous processes coming out. So here we have the anterior longitudinal ligament, the front of the bodies of the vertebra, so the very front of the spine. And here's the blue is the posterior longitudinal ligament. So you can see how they're, in the cross-section from the side, how they're hugging the bodies of the vertebra. Yeah? All the way head to tail. I hope that's clear. This is another view of the sacrum and how that works here. Again, we have red for the anterior and blue for the posterior. So you can see that it goes all the way down to the tip of the tail, those longitudinal ligaments. So there's a through line, basilar portion of the occiput to the tail. Yeah, both along the front of the vertebral bodies and along the back of the vertebral bodies. Yeah, the other two main ones, oh, here's a picture. Again, I apologize, the colors don't match up. This is showing, for some reason, just the anterior. Oh, that's why. Okay, so in this image of the skull, it's showing the anterior longitudinal ligament here in red. That's the basilar portion of the occiput where it's connecting on the top. So it's not showing the posterior because the posterior connects on the superior surface. Am I right about that? Yeah. So the posterior you can't see because it comes up and goes through this little edge of the foramen magnum and attaches on the top side of the basilar portion of the occiput. Yeah, so this is anterior and posterior we can't see. It's underneath. Underneath from this orientation, which is really on top of the attachment point for the anterior longitudinal ligament. I hope that makes sense. So those are the two ligaments we have running along that are connecting at the front of the foramen magnum, the basilar portion of the occiput, and running all the way down along both sides of the bodies of the vertebra. Yeah, then we have, let's come back to this cross section, or this side slice. Yeah. So we have anterior, posterior. This swirly bit is meant to indicate the spinal cord. Yeah, that's coming through here. And the ligamenta flava, the next ligament back, is called the ligamentum flavum. It's represented here in yellow. Yeah, and it goes along, you get the language right, it goes between the lamina of the articular arch and protects the spinal cord. Runs from the base of the skull to the pelvis, in front of and between the lamina, and protects the spinal cord and the nerves. Yeah, so in this orientation, the red, again, is the anterior longitudinal ligament. The blue is the posterior longitudinal ligament hugging the body of the vertebra. In this hole here, between the back of the body and the articular arch, is where the spinal cord runs. Yeah, and then on the other side of the spinal cord, right, on the backs of the lamina, these yellow are meant to indicate these, indicated here in yellow. That's the ligamentum flavum. Yeah, so it connects right behind the foramen magnum to the base of the occiput. And runs all the way down. Let's see how far down it goes. Does it go all the way? to the L5-S1 joint. Yeah? So it goes continuously from, and that makes sense because after, that's where the lumbosacral plexus starts, right? And that's where the spinal cord branches off into the nerves that come through the little foramen in the sacrum and down into the legs. So we don't have spinal cord below that needs protecting below that point. Yeah, so that's why ligamentum flavum, occiput to L5-S1. And then the last one that's running in this orientation, what would this be? Along the vertical axis, yeah, is represented here in green. So it's one further back from the ligamentum flavum. It's called the supraspinous ligament. Yeah, and it runs along the very back of your spinous processes. So it connects spinous process to spinous process to spinous process to spinous process to spinous process, all the way down your spine. Again, offering a point of connection and relatability between those vertebrae, but in a flexible way that allows for all those movements of the spine. Yeah, so they're being held together without being squeezed or fixed together. Yeah, so, and that one, let's see how far that one goes down. From the occipital ridge down the posterior surface of the spinous process to the posterior surface of the coccyx. So it goes all the way to the tail. So that's pretty cool. So there's another ligament that goes head to tail, literally, all along the back. So we have one that goes head to tail all the way along the back of our vertebra, and then we have two going head to tail that are hugging the front of our vertebra, the bodies of our vertebra. And if you look at, let's see, the other drawing I put up, well, there's this one, which offers yet another color combination, which might confuse you further, but it has I think it's a nice side view, akin to this one. Yeah. And then, sorry, my phone again. And then this one, so one last thing I want to say about the anterior longitudinal ligament and posterior longitudinal ligament. So I hope this is clear, that you can see this. In this one, this is up on Google Classroom, you can see this is the anterior longitudinal ligament, yeah, running along the front of the bodies, and the posterior longitudinal ligament you can see poking up here in the back. But you see that between the anterior and the posterior on either side, there's not a ligamentous support. So it's in the front and the back, but it's not on the sides. And no surprise then, remember when we were talking about the disc herniations and bulges? Yeah, when the nucleus pulposus squeezes out and impinges potentially the nerve, it's going to pop out. That's why you get those bulges or herniations usually on the side, not to the front or the back, because to the front and the back of the discs are being contained by those anterior and posterior ligaments. Yeah, it's here on the side where there's not that hugging support happening along the sides, so it's more vulnerable than to herniate out the side. So I thought that was kind of interesting, or that helped me sort of visualize how that happens with the discs. So let's see. I think that's kind of all I wanted to say about the ligaments. Again, I just like knowing that they're there, and that they're there offering another form of support that I don't have to do, right? So it's another layer of support that's available to us that we can call upon, recruit, learn to trust, learn to rely on, that doesn't involve recruiting big muscles and unhelpful muscle patterns. So for me, the idea of knowing that all of that support is there for me without me having to do anything is really helpful. So yeah, play around with that with Nanette and Peggy. I find doing, and you can do this on your own too, playing around with doing just basic spinal movements, roll downs and side bends and maybe some cat-cows, any kind of spinal movement, and thinking of whatever movement you're doing, having the support of those continuous ligaments that are running all along top to bottom, I think helps layer in this sense of continuity on top of all the segmentation and the movement possible between all the little vertebrae that we've already talked about. So in the spine, in the construction of the spine, in the anatomy of the spine, we have both the small little articulations between discs and vertebrae all the way up. Yeah? And we also have this this movement that's more about moving through the whole, more about moving head to tail, and about the relatability and the continuity of the spine, the connectedness, the literal connectedness of head to tail through these ligamentous fibers. So yeah, food for thought, and I will see you for one last lesson next week, and in person on, I think, the 20th next week. Okay, so thank you, and have a good week.